this video, we're talking about even and odd trigonometric identities and how to prove a trig equation using these identities. So in this first example, we have sine of 3 pi minus 2 theta is equal to negative sine of 2 pi minus 3 theta. And we've been asked to use the even-odd identities to prove that this is true. So obviously, since we're dealing here with sine, we want to find the even-odd identity that's for sine, which is sine of negative u is equal to negative sine of u. So really all we want to do here is match up our equation to the even-odd identity to prove that they are equal to one another. So what we could do is recognize that on the right side of our even-odd identity, we have negative sine of u, so that negative sign is out in front. And in our equation here on the right-hand side, we have negative sine of some value, so that negative sign's out in front. So we really want to say that these right-hand sides match up with one another. And if we do that, we can say that this u value inside of this negative sine function is this value right here, 2 theta minus 3 pi, which is also inside that negative sine function. So we would want to go ahead and say u is going to be equal to 2 theta minus 3 pi. Now if we've said that u is 2 theta minus 3 pi, then what we can do is take this value, plug it into our even-odd identity, and see if the equation that we get matches the original equation. So if we plug that in here, on the left-hand side we have sine of negative u. So we're going to say sine of negative u. So we want to put a negative sign and then a parentheses to make sure we get this negative sign distributed. And then we can go ahead and set that equal to this right-hand side, negative sine of u. So negative sine of 2 theta minus 3 pi. Now if we simplify this, we'll want to distribute this negative sign. So we're going to get sine of negative 2 theta. A negative times a negative is a positive, so we end up with plus 3 pi is equal to negative sine of 2 theta minus 3 pi. And then if we flip around these two terms so that we're not leading with a negative sign, which is always ideal, we have positive 3 pi, so we'll start with positive 3 pi, and then we have a negative 2 theta, so we'll say minus 2 theta is equal to negative sine of 2 theta minus 3 pi. And what you can see is that this equation here exactly matches the original equation we were given, so we've used the even-odd identity to prove that this equation is true. Same thing here with cotangent of 9 minus 7 theta is equal to negative cotangent of 7 theta minus 9. The even-odd identity for cotangent is cotangent of negative u is equal to negative cotangent of u. So this happens to be the same format as the even-odd identity for sine. Not all of the trigonometric functions have exactly the same format for their even-odd identity, but cotangent does. We'll go ahead and solve this a slightly different way just to show you a different method. In this case, we'll start out the same way. We'll notice that our right-hand side is negative cotangent of something, and the right-hand side of the even-odd identity is negative cotangent of something. So we'll go ahead and say that this u value here is going to be equal to our 7 theta minus 9. Then we can go ahead and say that u is going to be equal to 7 theta minus 9. We know here on the left-hand side we're going to need negative u, so we could go ahead and make this negative right here and say that negative u is going to be equal to negative 7 theta minus 9, which is going to be equal to negative 7 theta plus 9 when we distribute the negative sign. And if we flip around those terms, we get 9 minus 7 theta. That's the same thing. Now, if we plug everything back into our even-odd identity, we get cotangent, starting here on the left-hand side, cotangent of negative u. Well, we already found that negative u was 9 minus 7 theta, so we get cotangent of 9 minus 7 theta is equal to, on the right-hand side, we have negative cotangent of positive u. Well, we said u was equal to 7 theta minus 9, so 7 theta minus 9. And what you can see is that we've gotten here back to the original equation that we started with, and since they match, we've been able to use the even-odd identity to prove that this equation is true. Could you use some extra help with math? Click the button to head over to calculusexpert.com. It's where I've collected and organized all of my best resources, including exclusive videos, notes, quizzes, and even formula sheets. It's the perfect resource whether you're struggling, or if you want to take your learning further, or even if you just want to save yourself some time studying. So check it out, because I know it'll help.